Then our next speaker is Karen Tovmasyan. I really hope that I pronounced his name correctly. Karen, was that anywhere near?
Amazing job. Goed gedaan. My name is Karen Tovmasyan. Hello, everyone. I'm happy to see you in AWS Community Day Amsterdam, or should I say it Netherlands, or should I say it global? So yeah, my talk is going to be about CloudFormation, SAM, and CDK tips and tricks, which are not so well hidden. So let's start over. As my time is very limited, and I think I have about 13 items I want to talk about, and I broke down this talk to three major topics. So the first is going to be CloudFormation, my best friend ever. Then I will share some small tips and tricks on SAM and CDK. Those products for me personally are still young, especially CDK, but there is a lot of stuff we will see in future, hopefully. So I will need my laser pointer. I'm going to start with the CloudFormation, and I'm going to start with security as one of the most important topics ever. So the first item is CloudFormation service roles. Now, CloudFormation service roles are the IAM roles, which are used by CloudFormation in order to perform stack operations. The trick is that when you run stack operation, let's say you create stack, you update stack, you create a change set, execute a change set, if you don't specify the role, the CloudFormation will use your credentials, which on one hand is very insecure, as you will have to provide every engineer with full admin powers or superpowers. And at the same time, if you use the build agent, then you have to use the build agent, run an IAM role, or provide an API key to the build agent, which is also non-secure. So the trick with the CloudFormation service role is that what do you think will happen if you create the CloudFormation stack with the service role and then you delete that role? Now we know that, hopefully you know too, that the CloudFormation service roles are attached to the stack. You can use one role for the multiple stacks, but still, if you delete the role, then you cannot perform any other CloudFormation actions anymore. What you will see is that it will try to assume the role, but the role is not there, and then it just pumps errors. And then if you have a lot of time, try to create the same IAM role, not the same IAM role, but the role with the same name, and you will see very interesting error message, which is, I assume, is taken from the guts of the CloudFormation middleware. Anyway, keep the role safe. However, if you accidentally have deleted the role, you can still attach a new one by running the update stack or delete stack if you need to clean up the infrastructure. Next up in our list, the CloudFormation Stack Policy, another very interesting secure item, but this is about the resources which CloudFormation is allowed to perform in the stack that it has created. Now, the trick with this one is that you don't need to specify the exact physical ID of the resource, and you don't need to use the wildcards. Here, you will have to only use the logical name of the resource. Now, take a look at the example on the left. So you have the deny policy. So I'm saying in the stack policy, hey, you are not allowed to run put bucket ACL, put bucket policy. I disallow you. And I disallow this to everyone, but this is a stack policy, so this is by the CloudFormation. And at the moment of this talk, and I hope they will change it later, the principal must be wildcard. So the stack policy doesn't allow using other principals like AWS account or the service. Right now it has to be wildcard. That's the technical limitation for some reason. Doesn't matter anyway. Look at this one. I use the logical resource ID and then the /, and then I use the logical name in the stack policy. Now this tells me that on this particular resource, I am disallowed to run this particular action. On the rest, I can do whatever I want. On this one, on the other hand, I say, hey, I allow you to do everything, but not on this kind of resource. And then again, I mentioned the logical resource IDs, and I say, hey, you can do whatever you want, anything I tell you, but not on these super very important database instances. Now, this is useful when you have the resources which you want to protect, not from the AWS's API side, like termination protection, deletion protection, and so on, but from the CloudFormation. And you can store the stack policies in the same directory or in the same repository. As you can see, I can use create stack call to attach the stack policy, or I can use the set stack policy and then still add the body of the policy. The policies are written in the JSON format as usually for IAM roles. or IAM policy, so that's not going to be any use for you. CloudFormation Conditions. Now, the CloudFormation Conditions is how you make your templates truly universal. Now, imagine when you have to run you want to create a template with a set of workloads or a very big workload, which you want to then provide, maybe let's say as a service to someone, or you just packaged your resources in a single major template and you want to be as universal, as customizable for everyone you need. On the left screenshot, you see that I'm using the conditions. And the conditions are some conditional operators like equals, doesn't equal, etc., with some parameters. So I have the environment type of string with the load values def, test, and production. And I say, okay, this condition will be true, is test. This condition is existing, there it is there, if the parameter environment equals test. I cannot use condition as like if condition is not met. So I cannot say here, I have this if is prod. I cannot use not is prod. I must use string name, string value, which is the name of the condition. So in this case, I have to create two conditions. The one is test, where my parameter nth equals test. And I have the second one is prod, where my nth parameter value equals, guess what, prod. In the instance type property, and in this example, I use the condition to set different properties for the certain resource. I say, if this condition is met, so if the environment is production, I want you to use this size of an instance. If not, then I use another if, so it's going to be nested conditional check. So if not this, then another if saying that if it's is test, true, then use T3 large. And in the end, like you have this if, elif, and then else, use T3 small. However, that works only for the resource properties. Now, what happens when you need to have the resource-wide attributes like deletion policy? On the right, you see the following. So I want to have the production DB, but depending on the environment, I want to have the different deletion policy. It has to be either delete or take a snapshot or retain. And I have to define different logical names of the resources, but still I use the condition. So if the condition is production, then I will have the production database with the deletion policy retain. If not, it's going to be a test database with a deletion policy snapshot. Now, I'm already 7 minutes in the talking, so I have to hurry up. CloudFormation AWS-specific parameters. Now, you can use numbers, you can use lists, you can use strings, but that's not safe. Why? Because you will provide then subnet ID or the VPC ID, something which has to be validated. And CloudFormation AWS-specific parameters can check if the parameter is correct. So I can either provide it like this, like an object-wise. I can provide a list of AWS-specific parameters, or I can even put the quotes here. Nothing gonna break. The trick is that with the CloudFormation AWS-specific parameters, I can validate if the parameter value I pass not only is correct, but also exists in region. Now imagine if I want to use the key pair, which doesn't exist in region where I deploy my stack to. If I don't use the specific AWS-specific parameter, that will break during the deployment. With this kind of check, with this kind of parameter, I can verify this if I made a mistake before, during the validation step. This is very important and very useful when you want to fail fast as you can. Now, the next one is the CloudFormation StackSets in organization. Now, previously, you had to use account IDs to deploy your StackSets. And if you don't know what StackSets are, this is the mechanism to centrally manage CloudFormation stacks across the organization when you have tens and hundreds of accounts. You can deploy to the different accounts, you can deploy to the different regions. Now, the trick is that previously you had to specify account ID one by one, which would be troublesome when you have a lot of accounts. Let's say you are a training company and you have this sandbox accounts like Linux Academy, CloudGuru, and other training companies do, and you want to manage them centrally. You don't want to retain the list of the accounts IDs. Now, what you can do now is that you can use organizational unit IDs. For that, you must use permission model called service managed. That would mean that you allow CloudFormation StackSets to manage IAM roles and policies on your behalf across the whole organization. And this is done on the master account, management account, as it has to be called. So what I do here, I say, I want to have the StackSet name foo. I do that in the management account. I want to give this template body, and I say, hey, permission model service managed. Then I start by creating the stack instances. specifying the StackSet name, and then I provide the organizational unit IDs instead of accounts and the regions I want to deploy to. Next in the list, CloudFormation Helper script. Now, in the modern days, you would use some configuration management tools or SSM to manage your EC2 resources, but there is still a possibility to manage your resource configuration using CloudFormation metadata key called AWS CloudFormation init and using the helper script. The helper scripts are very handy when you have a small workload and you want to have like a central code where you have your configuration defined for your resources. This works for the EC2, and it works not only for the Amazon Linux EMIs, but also other EMIs like Ubuntu, Debian, and others, but you will have to install the helper scripts manually. You can use CloudFormation CFN init, as you see on the left, to say, hey, I want to go to this stack, I want to go to this resource, and I need this config set. And I also specify the region because I have to. If I don't specify it, as far as I know, it will take the default region, but it's very it's good if you use the region, use the AWS value AWS region, so you can go to the region where your stack is deployed to. And then I say, all right, I want the stack name. Now notice that it will go to the CloudFormation stack. I don't need to provide this EC2 instance with specific IAM roles. It doesn't need that. That's the tricky thing. And here in the AWS CloudFormation init, I have the config set, the only one, called base. And I say, I want you to install HTTPD, which is Apache web server. And I say, I want to have this HTTPD daemon running and enabled. Very handy when you have a super small workload, but still, if you manage a complex infrastructure and you want to divide the provisioning part and the configuration part, I will still advise you to use SSM for that. Now, the next one is the CloudFormation include macro. Now, the CloudFormation include macro is one of the two AWS's provided macros. The first one you might guess is the serverless transform, which we will talk a bit later. However, the include macro allows you to ingest the boilerplate code wherever you want, but not perimeter section. Perimeter section is a boilerplate code using template macro. Include macro is not supported. However, you can place the part of the template, which has to be stored on S3, in any place of the stack, where it is in any place of the template you need. And you can use the variables and the parameters, which will then refer to that part, or also vice versa. So in this example, I just demonstrate how I use it. So I have the resources section, I have one kind of resource, and I have another kind of resource, and then I just place my insert saying I want to have this AWS include, and I want this location to pick the template. Note the indentation, not the indent. So if I use the indent like this, so the same line as the resource, that would mean that the template will be on the same indent. So if I would have placed another resource here, I would like to do the indent 2 spaces to the right. Keep that in mind when you work with it. Now, another one, a very long-awaited feature by me, is that you can disable rollbacks on CloudFormation. Now, take that, Terraform. I personally very much so love the CloudFormation rollback ability, because I want my infrastructure to be healthy, even if I make a very messed up situation, if I make a terrible call, if I make a typo, whatever. But sometimes, let's say I create a stack which has the database, which is restored. It's an Aurora cluster, a global one, which is restored from the multiple from the snapshot, and it takes like an hour to deploy. And then I have another dependent resource, and I make a typo. The whole stuff will go back to the very beginning when I failed, and I have to spend another hour to do that. Really not helpful in regards to performance. This is only the disable rollback feature is only supported in the creation of the stack. Now, I think that there is a chance they will add it for the other parts of the another stack operations, like when you execute the change set or you run the update stack call. But still, I understand the reasoning why they only did this for the create stack. Now, if you do the create stack with the disable rollback and it still fails, still you can continue provisioning your resources, just fix your typo and run create stack again, because your stack is still not created. It's in the create fail state, and to use that, you only need to provide this argument called disable rollback. Now, these are my most favorite 8 items on the CloudFormation, and I'm going to move to the SAM, which is a serverless application model. Now, serverless application model is the one of the most famous macros from CloudFormation team. By the fact, when you create the serverless application models template, what will happen when you create this template is that CloudFormation will transform your template to the CloudFormation template, which allows you to write less code and have another layer of abstraction specifically designed for the serverless application. Now, one of the very useful features are the SAM globals. The globals are the template-wide properties where you can define resource properties to be used by every single resource in that particular stack or template. This, for example, take a look at this one. I have a function, which is the kind of resource in the serverless application model. As you can see, AWS serverless function. It can be a simple table. It can be API. Doesn't matter. It's the property of the serverless function. And I say timeout 30. For every function I create in this template, this timeout will be set automatically. I can define another property. I can define the runtime. I can define, I don't know, I'm not sure if the events are supported, but there is a list on AWS documentation which kind of properties are supported. Not all of them are supported. Keep that in mind. However, I still can override it. So if I have several functions which are fine with the timeout 30, but I have one function which is very heavy and fat and slow, I can say, hey, you are allowed to have 60 seconds of a timeout. Next. Kind of an obvious one. However, people tend to think that they can only use serverless application model specific resource in the template. That is not true. As I said, SAM is the transform. CloudFormation will still understand that if you use CloudFormation kind of resources, like let's say you have a serverless function which has to run in the VPC. It needs to access the file share, for example, or it needs to be on a private network for any reason. I want to define it in the same template. I can say I want a resource subnet type AWS EC2 subnet. This is the CloudFormation specific resource, and I can still create the serverless resource by just referring to the CloudFormation specific resource to this, and they will work. That's not a problem. Transform macro will only transform the resources which are serverless. So the SAM CLI and the CloudFormation, they understand this small bit. They don't care about the rest. CloudFormation understands that it doesn't need to transform the resources which are not serverless ones. Now, this is it for the SAM. SAM is a very small application, a very small management and provisioning tool. So there is not too much I can cover on this one, but next up, the game changer, the true integration of the application code with the infrastructure code, something I've been waiting for a very long time, even when the Pulumi was released with the version 1. And everybody loves CDK. It's a game changer. I believe Terraform is also implementing CDK TF. I guess they decided to be more friendly with AWS, but doesn't matter though. The trick is that the CDK brings you CDK assets. Now the assets are how you bundle your application code, your application artifacts with the source code. Now you can do it at this moment. You can only do either Docker container, but what you will do, you will specify the path to the Docker file. So what CDK will do is I say, hey, this is the image, and I want to use the Docker image because I will deploy my application in the ECS cluster. And I say, this is the path where my Docker file resides. And then I create the task definition for the ECS, specifying the container which will be taken from the asset I just declared right before. So the trick is that when I run this the CDK code and I deploy it, what will happen is that the CDK will build the image, push it to the ECR, and then create the task definition, which will pull that image from the ECR. I can combine, finally, 2020 or 2019, whenever it was released, not sure though, thank you so much. I can combine my application code with the infrastructure. This is that bridge I've been waiting for a long time, and I hope they will build more using new developments like Copilot and others. Next up, CDK Multi-Stack. Now, when you create an application and you define the stack, normally it would be a single stack, one application equals one stack. But let's say you have a diverse team and they all work in their own pieces of infrastructure. You can still define stacks, which are the part of the core stack, And they can be different files, they can be in the different repositories and locations, but still, I can create multiple stacks. And when I run CDK synth, there will be several stacks, CloudFormation stacks. And if I have a resource, let's say in the stack 1, I create a VPC, which ID I want to share with another stack. I can expose the field, the VPC resource, to the field of the class stack 1, and then refer to it in the stack 2 or stack 3. And I can also use them here as an argument. What will happen is that CloudFormation will use exports and import value to have this communication between different stacks automatically without my intervention. Now, when you have multiple stacks and you have multiple people working on it, you want to do testing on it. Now, the best part of the CloudFormation, the infrastructure as code, is that you can do the unit testing on your infrastructure. Now, how you do that? Only thing you need to do is you need to actually check the state of your infrastructure, if it would be rendered correctly. In this unit test, I check if my VPC has public subnets. Fair enough. So I just declare this construct. I take the subnets from the part of the construct, and this is the exported value field from the class core stack. And I just run the default assert true select subnets has public. Simple as that. Now, what I can also do, if I want, I can check against the rendered CloudFormation template. Now, what I do here, I then again declare the construct. I create the stack using synthesize, and I take the stack from the application, and I say, all right, I want the resources from the core stack, and I want to check for the role, which starts with developer. So what I'm doing in this test, I want to check that the developer role doesn't have admin powers. So what I just do, I say, hey, I want to see if this resource, developer role, doesn't have these. If you're working with CloudFormation, you know what it is. So it's the fn join IRN AWS partition IAM AWS policy administrator access, which is the managed policy from AWS for the admin access. I believe this is the last one. I'm sorry I had to be very quick and I'm out of my time, but I have shared the slides on the slide share, and you can see the recording if you want to reverse to the back and see what I've been explaining to. I thank you very much for your attention. I'm ready to answer your questions if you have any. If not, I'm very happy for your feedback. Let it be in the Rotten Tomato or thank you messages in the group chat. If you want, you can scan the QR code or type this link. It will guide you right to the slide share where this deck is shared. Slideception. And I pass the mic to you, Walter. I feel awkward silence. Have I been online? Because I cannot hear Walter. Walter, are you with me? Please come back, I'm scared. All right, for some reason I cannot see Walter, so I'm gonna check him on Slack if he's there or not. Because I'm happy to be with you guys. Oh, there you are. I missed you. I cannot hear you.
Too many mic buttons these days. Mute buttons these days.
I feel your pain, man. I feel your pain. All right, I'm gonna mute myself.
Yes. Can you hear me? Can I hear you is a question also.
You can hear me, but I'm muted, so yep. I pass the mic to you, so you have the word.
Yeah. Okay. Great. Well, thank you very much, Karen. That was really quite interesting. There are, of course, some questions on whether you will share the slides, but I presume by now, if it wasn't clear already, that most of us will do this. There's one interesting question that asks, if you start with a clean new infrastructure on AWS, would you use CloudFormation or CDK, and why?
Are we talking about 2020 or a few years before? That was a rhetorical question. If I would be there right now and I start my brand new workload right away, I would use CDK. But that also depends on the kind of business you work with. So take a look at this perspective. If you're a small startup and you have a bunch of developers who don't want to learn yet another tool, but they are very good with the programming languages of their favor, they can use CDK, because they will grow bigger and bigger afterwards, and they will figure out if they need to change the tooling or not. But if you work with in the major companies, organizations which use heavy workloads, multi-account strategy, and so on, they might have a checklist on compliant resources, and CloudFormation is complied with many industry standards. So people are used to it, and it is easier to find the person who is very good with CloudFormation, and it's a bit hard to find a person who is very strong with CDK, because CDK was only released last year.
Yeah, this is actually my my main problem with things like CDK. Like I came from a Puppet background, so Puppet and Chef was exactly the same debate as Terraform versus CDK. You know, in Puppet everything is very well defined, in Terraform everything is super well defined, but then Chef gives you the power of a programming language, and so does CDK. And that's really awesome. But I have seen how this works out in enterprise environments where you not only expect lots of people whose not main job infrastructure. So they're, for instance, maintaining an application, and now they need to learn CDK plus programming plus version control plus Git plus a whole bunch of stuff.
And then you have the security operations center who's jumping in, who say that this tool is not safe. Yeah.
It's quite an interesting situation. While it's technically, if the world consisted out of technically gifted people, no question about it. But especially that enterprise segment and the larger businesses deal with so many teams that is unfortunately not such an easy story.
Let's just hope we get there sooner. The CDK is growing really quick and really fast. And with the recent releases of CDK Kates and CDK TF, I want to see what happens in the next year.
Yeah, I mean, I think we'll see some more development in this. The last word hasn't been spoken about it. So, in general, thank you very much for your session. People can rewatch it here on the Grip platform or on YouTube. We're also streaming live to YouTube. By tomorrow, we will we will cut up the session as well, so that we have individual videos for everyone. Which leaves me. Do you want to say anything? Any last remarks before you?
I would like to thank you guys for the organization, and thank you for being here. This is very important these hard times, that we can still communicate to each other and talk to each other. The benefits of physical contacts are out of out of estimate. They cannot be evaluated, but at least we have this even online connection. So thank you very much, guys, for the organizing these talks. I hope my talk was useful, and I have only one last word to the people who are still leveraging CloudFormation SAM CDK. If they're afraid, please use it. There is nothing to fear. If you're handy, if you have experience with this, share your knowledge as I did right now. There are way more things which you can do with CloudFormation, and I just hope that I will see the same session from somebody else.
Nice. Thanks for the words, and thanks for all your effort in making this session. That's, I know firsthand that how much time goes into preparing a session. So
you're more than welcome, and and I see you soon again, guys.
Yes, awesome. Thanks, Karen.